Hello everyone, my name is Arjun and today I am thrilled to take you through a technical deep dive into this yoga AI pose detector called Yogadṛṣṭi. This project is an AI powered system designed to analyze your yoga postures and provide real time expert level feedback to ensure a safe and effective home practice. The inspiration for this project is deeply personal. For over a year now, I've practiced under the guidance of Yogini Kamini. Kamini is an amazing instructor, but like most people, I only get her expert guidance for an hour a day at the center. The problem is when I practice at home, I'm on my own. I wanted a tool that could bridge this gap, something that offers even a small proportion of the inputs Kamini provides and helping me maintain my form when Kamini is not there to guide me. Of course, I want to be clear, no digital surrogate can ever replace the human touch. However, this tool acts as a humble pocket instructor. It honors the teachings of Yogini Kamini by helping me stay mindful of my alignment during my solo sessions, acting as a supportive aid on my journey towards mastering more complex asanas. Now, why was it hard to build this tool? Because building this isn't just as simple as a standard image classifier. UK poses assessment using AI is challenging for four main reasons. One is the inherent variations among the asanas. Distinguishing between 82 yogic poses like Warrior 1 was and Warrior 2 requires high level and high precision skeletal analysis, and we don't just want to know what the poses, we want to mathematically calculate the joint deviations and assign a score. We'll get to that later, and I will be explaining how that is done in this particular project. And apart from that, the problem of scarcity, high quality alignment data is often hidden behind paywalls, and getting access to that is not that easy. And the dataset that I'm using here is the Yoga 82 open source dataset. It doesn't have a lot of high quality images. So that's always the challenge. One needs to have a vast repository of high quality images captured from different angles to ensure that the accuracy of the model is extremely good. And the last concern why building this particular model was challenging is because of the safety issues. Incorrect posture will lead to injuries, and therefore it's necessary to ensure that accuracy is not just a critical requirement, but it's an embedded feature. How does it work? The pipeline follows a robust four-step process where the user provides a photo of their asana, and as far as possible, the asana should, the image of the person performing the respective asana should be as clear as possible and should be taken in an overhead manner if possible. And for the estimation of the pose, I use MediaPipe to extract 33 precise 3D body landmarks, and which creates a digital skeleton replica of the individual. And for the classification, I use a custom trained multi-layer perceptron model which identifies the specific pose from one of the 82 supported yogic poses in the dataset. And for the scoring, I use a geometric rule engine which compares the joint angles against the perfect form, which is the benchmark to generate a score. What powers this project is this technical stack. I use FastAPI for a high performance Python backend and React with Vite for a snappy frontend. Data persistence and storage is handled by MongoDB Atlas, and the entire environment is containerized with Docker to ensure consistency across any machine. This stack allows us to handle complex AI calls while maintaining a seamless user experience. The brain of the system is a two-part engine. For classification, I've designed a custom multi-layer perceptron with batch normalization and dropout for better generalization. It achieves a peak top one accuracy of 81.3% by learning the deep structural symmetries of the body. And this figure is quite impressive for this particular model, considering the images that it has been trained on. And for the feedback engine, I use Google Gemini 3.1 Pro, and I ground the AI using prompt engineering along with Sanskrit names as primary keys, ensuring that the feedback is based on authoritative sources only, like Tummy and Yoga Point, which are two credible yoga resource materials available online. And this helps translate the raw math into human friendly instruction. The system is trained on a massive range of 82 yogic poses, from foundational ones like Tadasana to more advanced asanas like Bakasana and Shirsasana. You can see a snapshot here of the diversity our model handles. I won't go into the screenshot shown in later slides of this deck right now, as I'll be walking you through the live application in just a moment. So for the scoring, I'm using a deterministic rule engine to calculate the deductions, angular deductions based on how the particular individual's joint deviations vary from the standard benchmark. If the LLM ever fails, I have a template based fallback to ensure that you always get feedback in any case. And looking, and before I get to the demo, I would also like to tell you that the persistence, data persistence is handled by MongoDB Atlas, and user can create their profile and they can track their progress over time. And for each asana, they can track their progress over time and they can view the suggestions as well as the feedback that they've received. And all this data is securely stored and does not get leaked anywhere. And for the login, there is the email normalization and deduplication process for a seamless experience to access this app from any device. Looking ahead to the version 2.0 of this app, I'll be moving towards real time video analysis and also integrating vision transformers for even higher accuracy. Now, let's move from the theory to the practice. I'm going to jump over to the live application to show you exactly how this works in a real world scenario. Welcome to the live dashboard. As I mentioned, the heart of this project is about bridging the gap for home practitioners. Here, I'm going to be starting the FastAPI backend as well as firing up the front end. I'm going to start the FastAPI backend on port 8000. It's going to connect to the MongoDB Atlas, and the persistent data storage is going to be up and running. And now I'm going to fire up the front end. Here on the landing page, you can see the clean, intuitive interface designed for ease of use during a workout. Okay, a huge shout out to Kamini. Her guidance in class is what defined the logic of this pocket instructor. It's built to be there for when I practice alone. The front end you're seeing is built with React and Vite, making it incredibly responsive. Let me register a new profile since I like satire a lot and use satirical references in many of my posts and in many of my day-to-day conversations. I'm going to go with the username as Arjun Cockroach. I'm going to create a profile and let's actually test the system. I'm going to upload an image of an eagle post done incorrectly in an incorrect manner. Garudasana. And when I click analyze, the FastAPI backend kicks in. It's currently running that MediaPipe landmark extraction we discussed and feeding it into a custom multi-layer perceptron with 82 possible yogic poses. The classification has to give the correct. And here are the results. The system correctly identified the pose. You can see the score here, but more importantly, look at the feedback that is provided here. It says that the person is doing a good job on the eagle pose or garudasana, and there are some suggestions for improvement such as adjusting the left elbow, right elbow, and so on. And it suggests that if you cannot trap fully, just cross your arms and legs. And apart from that, there are also the health benefits of this asana. It strengthens the calves, ankles, opens the shoulder, improves joint flexibility, etc. And there's a common disclaimer stating that this is only for educational purposes and it's not a substitute for professional guidance. And apart from that, there is a history here of all the previous and the current uh, scoring of the eagle pose done by this particular individual in this particular profile. And this record is stored in the persistent storage. Give an incorrect version of this particular eagle pose Garudasana, where the person is clutching hands and the alignment is not all that accurate. And if I give this to the model to analyze, this is where the Google Gemini 3.1 Pro shines. It takes the raw joint angles from our geometric rule engine and translates them into encouraging, actionable tips. It tells me exactly what I'm doing well, like my arm wrap, and where I need to focus, like squaring my hips. This data is now stored in the MongoDB Atlas so that I can track this specific pose over my next few sessions. As you can see, this the score is reduced from 87 to 75 and needs adjustment since this person is the alignment is not all that accurate and also the form is missing and this person is not doing the asana in its optimal manner. This time I'm going to be taking the Navasana or the boat pose, and first I'll go to the incorrect version of this. And as you can see, the score is just 46. This person is bending her knees, and the torso is not as how it should be when one is performing the pose in an optimal way. And it gives instructor feedback that powered by the Gemini 3.1 Pro model. And it says that the person has to straighten their legs and lift their torso a bit higher, and the legs have to be straightened fully for this board pose. And here are some of the health benefits of this asana. Strengthens the kidneys, thyroid, intestines, improves digestion, builds core endurance, and improves the balance. And as you can see, the scoring is recorded here and it is persistent in the storage. Now let's look at the same Navasana but done in the correct manner and see whether the score improves or not. And also look at the suggestions that it provides. As you can see, the score has been bumped up all the way up to 92. This person seems to be getting the form absolutely right. The torso is up as it should be, and the legs and are almost straight the knee at the knee level, and the arms are perfectly parallel to each other. And it has the record of the previously attempted variant as well. And here are some suggestions. Keep your lower back from rounding and always engage your core. It tells you what you're doing well, gives suggestions for improvement, and gives the safety instructions for this particular asana, as well as what is the key area of focus along with the health benefits of this particular asana. Let's look at handling certain edge cases that the model has been trained to handle. Like, I built the system to be robust, it handles intra-class variance. The fact that everyone's body looks different, we also implemented a confidence gate to reject blurry images or non-yoga photos, ensuring that the output is only feedback when the AI is certain. This prevents the quote bogus feedback unquote loop that many simpler AI tools may fall into. So to test this in example, I'm going to upload an image, a non-yoga related image, let's say of my Babolat tennis racket, and I'm going to analyze this post. It immediately fails, stating that no person has been detected in this particular image. If I try to upload a photo with two people performing a specific yogasana, in this case, it is the Bhujangasana pose, again, it is going to fail, and it is going to say that multiple people have been detected in this image, in this case too, and please upload an image with only one person performing a yoga pose. The project has been a journey of combining my passion for yoga with the power of modern AI. I want to thank the creators of the Yoga 82 dataset for their foundational work. The quality of the images may not be great, but they have done a very good job in ensuring that this is an open source repository that researchers and students and hobbyists like me can experiment with. And most importantly, thank you, Kamini. Your clarity and support made this possible. You are simply the best at what you do. To everyone watching, I hope this tool helps you on your path to a safer and more mindful yoga practice. Thank you for your time. Namaste. Hasta la vista. Adios, amigos. Until next time.